Look up. Right now, just tilt your head back and look at your kitchen ceiling. What do you see? Because if you have been cooking in that kitchen for more than 2 years, what you're staring at is not just a yellowed, grimy surface. That layer has a name. That layer has a chemistry. And the fact that nobody ever told you how to remove it in under an afternoon for literally less than $1 is one of the most expensive pieces of ignorance most homeowners carry without ever knowing it. Stay with me, because what I'm about to show you is not a cleaning tip. This is a story about how an entire industry quietly buried a solution that has existed for over 150 years. And once you see it, you will never look at a grocery store cleaning aisle the same way again. If you are new here, my name doesn't matter as much as what you're about to learn. But if this kind of thing, real, useful, suppressed information that saves you real money, is something you want more of, hit that subscribe button right now and tap the bell. Because at SecretVerse, this is exactly what we do. Every single video. And like this one, if you plan on actually trying this today, because I want to know how many of you are sitting on a kitchen ceiling right now that cost nothing to fix. Let me start with the numbers because they hit differently when you see them laid out. The average American homeowner who calls a professional cleaning service for a kitchen, deep clean, pays somewhere between $150 and $400. In some major cities, that number climbs even higher when the technician looks at years of buildup on overhead surfaces. Grease around the range hood, discoloration along the upper wall tiles, a ceiling that looks more yellow than white. These are the categories that push quotes to the top of the range, and almost every homeowner pays it, because the cleaning industry, a market worth over $30 billion in the United States alone, has spent decades conditioning you to believe that this is a technical problem, that it requires professional equipment, professional chemistry, professional labor. What they never advertised is that the chemical reaction needed to dissolve baked-on cooking grease is something a box of powder you can buy at any hardware store has been doing since before your grandparents were born. Here is what is actually happening on your kitchen ceiling and why this matters. When you cook, particularly when you fry, saute, or use an open grill, oil particles become suspended in the steam and hot air rising from your pan. They travel upward and settle on every surface above the stove. At first, this layer is thin and invisible, but heat cycles through your kitchen day after day. Those oil particles oxidize. They bond chemically with each other and with the paint surface beneath them. Over months and years, they form what chemists call a polymerized grease layer. It is not a soft, greasy residue anymore. It is hardened. It has essentially baked itself into the surface, and spraying a bottle of commercial kitchen degreaser on it and scrubbing for 20 minutes barely scratches it. That is not a coincidence. That is a design feature of the products you have been sold. Now let me tell you what actually works, and more importantly, why it works, because when you understand the chemistry, you will never fall for the expensive alternative again. There is a compound called sodium carbonate. You may have heard it called washing soda. It is not baking soda, and this distinction is critical, so I will come back to it. Washing soda has been commercially available since the 1840s. It was a staple in households across the United States and Britain for over a century. You could find it in plain bags at every general store. Families used it on stone floors, on cookware, on laundry, on everything. It was inexpensive, widely available, and extraordinarily effective. Then something shifted in the post-World War II era. The rise of petrochemical manufacturing made it possible to create synthetic cleaning compounds at massive scale. Companies began producing branded detergents, surfactant sprays, enzymatic formulas, and degreaser concentrates. These products were packaged attractively and marketed with enormous advertising budgets. The positioning was strategic and deliberate. Cleaning was gradually reframed from a straightforward task solved by simple mineral chemistry into something requiring specialized branded solutions. Simple products, like washing soda, didn't disappear. They were just quietly buried under 30 feet of marketing. And here is the part that should make you a little angry. Those expensive degreaser bottles lining the grocery store shelves. Many of the major brands, the ones retailing for $8, $12, even $15, list sodium carbonate or closely related alkaline compounds as their primary active ingredients. The chemistry is identical or nearly so. What you're paying for is the bottle, the brand, and the advertising budget that convinced you that you needed it. So how does washing soda actually destroy kitchen grease when everything else just pushes it around? When you dissolve washing soda in hot water, it produces what is known as a strongly alkaline solution, measuring roughly between pH 11 and 11.5. That number matters. Polymerized cooking grease, the hardened layer baked onto your ceiling, is classified chemically as an ester compound. It forms when fatty acids from cooking oils undergo heat bonding and oxidation over time. Here is where it gets interesting. When an alkaline solution at or above a pH of around 10 comes into contact with ester bonds, it triggers a chemical reaction called saponification. The hydroxide ions in the alkaline solution attack those ester bonds directly and break them apart, converting the grease molecules into water-soluble compounds that rinse away cleanly. The grease is not being scraped off. It is not being coated and loosened. It is being chemically converted into something that dissolves in water. That is a fundamentally different mechanism from anything in a commercial spray bottle, and it is the reason this method works so well on surfaces that commercial products fail on entirely. Think of it like the difference between trying to soften a wax seal with a damp cloth versus using the right solvent. One requires effort and repetition and still leaves residue. The other changes what the material is. Now let me walk you through the exact method step by step, because precision matters here. There are a few common mistakes that cause this to fail, and I will tell you the biggest one before we're done. First, your materials. You need washing soda, sodium carbonate, not baking soda. This is the mistake that trips up the majority of people who try this for the first time. Baking soda is sodium bicarbonate, and its pH sits around 8.3. That is not high enough to trigger saponification at any useful speed. If you use baking soda, you will spray it, wait, scrub, get mediocre results, and conclude that the method doesn't work. The method works. Baking soda is just not the right compound. Read the label. You are looking for the words sodium carbonate, or the chemical formula Na2CO3. In the United States, Arm & Hammer makes a product called superwashing soda, yellow box, widely sold at Walmart, Target, and most grocery stores, typically around $4 for a box that gives you dozens of applications. In other markets, look for soda crystals, which is the same compound at a slightly different granule size. Both work. Baking soda does not. Second, your solution. Fill a container with 1 liter of water. As hot as your tap will produce, not boiling. Add 4 tablespoons of washing soda and stir until it fully dissolves. You will notice the water feels slightly slick against your fingers. That is the alkalinity. That is your working solution. Third, transfer the solution into a standard spray bottle. Work in sections, roughly 2 feet square at a time. Spray the surface generously. Do not mist it. You want visible saturation, enough that the solution is actually making contact with the grease layer and beginning to react. Then, and this is critical, do not touch it. Put down the cloth, walk away. Set a timer for 10 minutes minimum, 12 if the buildup is heavy. This is where almost everyone fails on the first attempt. People spray, wait 30 seconds, feel impatient, and start scrubbing. They get poor results and give up. The saponification reaction is not instantaneous. It requires dwell time to break apart those ester bonds at depth. 10 to 12 minutes is not optional. It is the mechanism. After the dwell period, come back with a soft bristle brush or a non-scratch scouring pad, not a dry cloth, and wipe in slow, deliberate strokes. What you will see coming away on the pad is a grayish-brown emulsion. That is the converted grease, now suspended in the solution, lifting off the surface. Wipe it clean with a damp cloth. For areas with years of heavy buildup, simply repeat the application once. Do not increase the concentration trying to speed things up. Beyond about 5 tablespoons per liter, the solution becomes harder to rinse cleanly and can leave a white mineral residue on painted surfaces. One specific caution worth mentioning. On ceilings, painted with flat or matte latex paint, particularly low-quality flat paints, test a small hidden spot first. High alkalinity solutions can in some cases slightly affect the sheen of this type of finish after repeated applications. On gloss, semi-gloss, and standard ceiling white paints, this is generally not a concern. But test first. It takes 30 seconds and protects you from an outcome you didn't want. Now, I want to talk about something broader, because the kitchen ceiling is just one example of a pattern that is hiding in plain sight all over your home. Soap scum in your bathroom, the chalky, filmy buildup on shower tiles and around the bathtub, is formed by ester compounds, in essentially the same chemical family as kitchen grease. The same washing soda solution at the same concentration handles it through the same saponification mechanism. The buildup inside your dishwasher that no dishwasher cleaning tablet ever fully removes, same chemistry. The mineral deposits on your shower glass, same approach. One compound, under $2 per use, handles every hard surface in your home. Think about how much you have spent across a lifetime of buying a separate product for every surface. Bathroom spray, kitchen degreaser, tile cleaner, appliance cleaner, shower glass solution. Each one claiming to solve the specific problem only it can address. Every one of them marked up to retail price with a different scent and a different color and a different problem printed on the label. The chemistry underneath most of them traces back to alkaline mineral compounds that cost fractions of a cent per gram to produce. Before you close this out, I want to leave you with the cost comparison in concrete terms, because this is what actually lands. A household kitchen ceiling that has not been properly cleaned in 3 to 5 years is categorized by professional cleaning companies as a heavy grease job. Standard professional rates in U.S. markets run between $45 and $75 per hour. This type of job typically takes 2 to 4 hours. That puts the cost between $90 on the very low end and upwards of $300 for a thorough job. The professional doing that work is, in most cases, using a commercial alkaline degreaser, which is chemically related to what you now have in a spray bottle, purchased in bulk and applied at professional labor rates. One homeowner with a kitchen ceiling that had been accumulating grease since 2018 documented removing it completely using 3 applications of washing soda solution over a single afternoon. Total material cost was just over $1. Another, dealing with heavy grease accumulation around an overhead grill vent, the specific scenario that cleaning companies quote at the top of their rate range, achieved the same result for under $1.50. These are not rare success stories. These are the expected results when the correct chemistry is applied correctly, with the correct dwell time to the appropriate surface. What I want you to sit with before you leave is this. The story of washing soda is not a story about cleaning. It is a story about manufactured dependency. The systematic replacement of simple, inexpensive, effective solutions with branded alternatives that require repeat purchasing. It happened in the cleaning industry. It happens in home maintenance. It happens across categories that most homeowners never think to question. And the mechanism is never conspiracy. It is just commercial incentive. Companies making money from your continued purchasing have little reason to advertise the existence of the $1 alternative. Now you know. And knowing changes what you do next time you're standing in that cleaning aisle looking at a $12 bottle of something that is, at its chemical core, a marked up version of a compound that has been sitting quietly on the bottom shelf in a plain yellow box for decades. Here's the question worth carrying with you. If $1's worth of powder has been solving this problem for over 150 years, and the industry made sure most people never found out, what other $300 problems in your home have a $1 answer? Drop that question in the comments. I want to know what you're thinking. And if someone you know has been spending money on professional kitchen cleaning or just dealing with a ceiling they thought was too far gone, share this with them. It costs nothing to send, and it might save them a few $100s. Hit subscribe if you haven't already, because the next video in this series goes somewhere you're not expecting. And once you see it, you will understand why these kinds of investigations matter more than most people realize.